Okay, so molarity versus molality. Both molarity and molality are measures of the concentration of a solution. So the following are terms that you should know beforehand in understanding the concepts that we'll be discussing in this video. So take a few seconds to make sure that you know all of these terms. And these two terms in bold, molarity and molality, are the terms that we'll be discussing in detail today. So, as I said, they're both measures of the concentration of a solution. So, starting with molarity. Molarity is represented by a capital M, and the units of molarity represent the number of moles of a solute divided by the liters of solution, which is the volume of the solution. This represents the concentration as a ratio of moles of solute to liters of solution. So, for example, a 1.0 molar solution of sodium chloride, every liter has exactly 1 mole of NaCl dissolved in it. These are some important equations that are helpful in working with molarity. First is the definition of molarity, which is moles over liters equals molarity. This can also be written as moles over volume. But it's important to remember that the volume has to be liters in order for the units to be molarity. The next equation is MV equals number of moles. That means that if you multiply the molarity and the volume in liters together, you should get the number of moles in a solution. Finally, when changing the molarity of a solution, M1V1 equals M2V2. This means that the initial molarity and volumes multiplied together are equal to the new molarity and volumes. So, if you know the initial molarity and the initial volume of a solution, and you know how much the new volume is, you can find the new molarity. Next is molality. Molality is the number of moles of the solute over the kilograms of solvent. Molality is represented by a lowercase m. So, molality is lowercase m, and molarity is an uppercase m. In addition, while both involve the moles of solute, in molality, it's divided by the number of kilograms of solvent. So, for example, in an aqueous solution where the solvent is water, you would use the number of kilograms of water. Be sure that you use kilograms and not grams. So, for example, a 1.0 molal solution of NaCl means that there is 1.0 moles of NaCl for every 1 kilogram of water. When changing concentration, there are two most viable ways to do this. You can either add solvent or add solute. When you add solvent, you dilute the solution, which means you decrease the concentration. When you add solute, you make the solution more concentrated. Then, if you add 1 mole of solute to the solution, you now have 3 moles over 1 liter, which means you've changed the molarity to 3 molar. When using molal units, a 2 molal solution is 2 moles over 1 kg. So, if you add 1 mole, you get 3 molal. If you add 1 kilogram, you get 2 over 2, which gives you 1 molal. So it's a decrease in concentration. The following are some practice problems you can use to practice working with molarity and molality. Try to work through them by yourself before I reveal the answers. So for the first problem, you are given moles of the solute and the liters of solution. You're asked to find the molarity. So, 5 moles over 10 liters. This gives you 0.5 molar. In this problem, you're given moles of solute and grams of solvent. The first thing we want to do is make sure that we're in the right units. Grams needs to be converted to kilograms. This can be done by dividing by 1,000. So we have 3.8 kilograms of water and 5 moles of solute. We're finding the molality, so we simply divide these two. Putting that in a calculator yields the following answer, 1.3 molal. Try the next few problems on your own and see if your answer is correct. Thanks for watching, and please subscribe.